Make search favor both relevance and freshness. By the end, you'll have a tiny Python pipeline that ranks news articles by text match, boosts rare terms, orders by date, and blends these signals into a single score you can tune. You will understand why time boosting matters, how a simple decay works, and what to tweak for your dataset. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Search for news or product posts has a special challenge. Users want answers that match their query and reflect the current situation. A top result from 2 years ago can be irrelevant today. Time-boosted search solves that by combining relevance with recency. It is not magic. Compared to dense semantic embeddings, a simple relevance plus recency approach is faster and more interpretable. But it can miss deep semantic matches, and it can over-promote new but noisy items. Intuitively, think of two axes. One axis measures how well a document's words overlap the query. The other axis measures how recent the document is. We want a score that nudges recent relevant items up without throwing out older, high-quality results. For example, for the query battery life, a classic review from last year may still be great, while a new firmware report might be more helpful. Time boosting lets you balance those. We will use a small corpus of news articles about mobile devices and product releases for every demonstration. You will see stepwise snippets that first rank by term overlap, then add IDF weighting, then sort by date, then blend with a time decay, and finally combine normalized signals into a simple baseline score. Now let us start with a basic relevance ranking. This snippet ranks toy documents by simple term overlap with a query. It shows how to compute a raw relevance score by counting shared terms between the query and each document, so common words are treated equally. This is the baseline that reveals why naive overlap can prefer long documents or common phrases. You will see how to tokenize, count matches, and sort documents by that count. If you change the tokenization to include bigrams, you will get more phrase sensitivity, but fewer matches per document. And if you switch from simple counts to binary matches, the influence of term frequency disappears. Next, we add weighting that prefers rare terms. This snippet applies IDF weighting to favor rare query terms in ranking. IDF stands for inverse document frequency, and it downweights terms that appear in most documents because they carry little distinguishing power. The snippet multiplies overlap counts by IDF weights so that matching a rare technical term lifts a document more than matching a common stop word. Adjusting IDF smoothing or adding a floor prevents extreme weights for singletons. Making IDF stronger increases emphasis on rare terms, which helps precision but can hurt recall when queries use common language or synonyms not captured in the text. Now we look only at time as a signal. This snippet orders documents purely by recency using a fixed reference date. It demonstrates a simple approach where each article has a timestamp and we compute days since the reference date, then sort newest first. The example uses a fixed reference date, so results are repeatable, like when evaluating or debugging an index. If you change the reference date to today, you will surface the most recently published articles. If you switch to a shorter window, for example 1 week instead of 1 year, you will drastically narrow the result set and favor only the freshest posts. Next, we combine relevance with a time decay. This snippet blends term matches with time decay, so fresher hits rank higher. It computes a relevance score from the earlier IDF weighted overlap and multiplies it by a decay factor derived from the document age. The decay can be exponential so that a document loses half its time score every fixed number of days, or linear when you want a steady decline. The snippet exposes a decay parameter and a relevance weight parameter. Increasing the decay rate boosts very new items strongly, while reducing it keeps older relevant documents near the top. This is the core idea of time boosting. Finally, we build a normalized baseline score. This snippet delivers a tiny baseline combining normalized relevance and freshness. It normalizes the relevance and time values to comparable ranges, applies a tunable weight to each, and sums them into a final score. Normalization prevents one axis from dominating simply because of scale. The snippet shows how to set a relevance weight between 0 and 1, so you can test extremes. Set weight high to prioritize text match, set it low to prioritize recency. Changing normalization strategy, for example using rank percentile instead of min-max, affects sensitivity to outliers and can stabilize results on small corpora. Recap in 3 points. What it is: a hybrid ranking that combines text relevance with document recency. When to use it: for news, releases, social posts, or any feed where freshness matters. One caveat: if you boost recency too hard, you may surface low-quality new items and miss older authoritative content. Next step: tune the time decay, half-life, and the relevance weight together on a validation set. Or swap the overlap relevance for a semantic embedding and keep the same time decay to compare gains. If you want faster production scaling, consider adding an ANN index for relevance scores and apply the time boost at rerank time. If short, practical IR helps, subscribe and watch the rest of the IR videos.